So hello and welcome in this video on continuous random variable. Okay, so today we will discuss about the problems on continuous random variable. So first of all, let us begin with the basic concept. So let x be a continuous random variable, and we are having a very important function which is related to every continuous function, is known as the probability density function, and in short we will call it as PDF. So this probability density function help us to determine the probability associated with the continuous random variable. Okay, and we can also solve this different problems related to the continuous random variable. So first of all let me discuss about the properties of this probability density function. So in general we have two properties. The first one is that this probability density function is always greater than equals to 0 for all values of x. So we are taking the general case, so we are assuming that for all x belongs to R, but you can also mark it as on the domain of definition. So means the set on which this fx is defined, or you can say the interval on which this fx is defined. And second is when you integrate this from minus infinity to infinity, so this integral always produces 1. And again the remark is that it is not always necessary to perform this integral from minus infinity to plus infinity. We have to consider this integral over the interval I on which this fx is defined. So here this I is the domain of fx, or you can say the PDF. So these are two very important properties, and these properties help us to identify whether a given function is a PDF or not. So in general we have two types of problem related to types of problem related to PDF. Okay, so we are having two types of problem. Sometimes some function is given, some fx is given, and we have to check it is PDF or not. Okay, so we have to check whether it is PDF or not. So in this type of problem we have to check these two properties, and once a function is satisfying these two properties, so certainly it will be a PDF. Now the second type of problem is sometimes it is given that fx is a PDF. Okay, and fx involves some unknown. Okay, some unknown, and we have to find the unknown. So in the second type of problem we always use this the second property of our PDF. Means we are well aware that the given function is PDF, so it must satisfy these two properties, and we know that if we integrate this PDF on the domain of definition, so certainly it will produce 1, and this property help us to determine the unknown involved in the function. So now let us discuss some problems on the probability density function. So let us discuss some problem. So we are given a function fx which is defined as e to the power minus x for x lies between 0 to infinity, and it is 0 for all other values. Okay, so you can say that 0 otherwise. So we have to check whether this function is a PDF or not. Okay, so as we know that in order to be a PDF, this function has to satisfy two properties. The first one is that it should be greater than equals to 0. Okay, so the first property is fx should be greater than equals to 0. So you can see that from if you consider the real line, because it is defined all on all real values or real numbers. So if you consider this real line, so this is minus infinity to plus infinity, and if we assume this as 0, so from minus infinity to 0 this function is 0. Okay, so from minus infinity to 0 this function is 0, and from 0 to infinity it is e to the power minus x. So if you look at this, so this function is always greater than equals to 0 for its all values of the domain, because from minus infinity to 0, as you can see that it is 0, and from 0 to infinity it is e to the power minus x, which is certainly greater than equals to 0. Okay, so first property is satisfied. Okay, so this is true for all x belongs to R, because this function is defined over the entire real line. So this first condition holds on R. Now we have to look at the second property. So because it is defined over the entire real line, so we have to perform the integration over minus infinity to plus infinity fx dx, and if this is a PDF, then this integral should come out as 1. Now this integral, because this function is defined in parts, from minus infinity to 0 it has one type of definition, and from 0 to infinity it has another type of definition. So you can break this as minus infinity to 0, and on this interval it is 0, and from 0 to infinity it is e to the power minus x dx. So because this here this function is 0, so this value is, the value of this integral is 0, and when you integrate this e to the power minus x, so it is coming out as minus times e to the power minus x, and when you integrate from 0 to infinity, when you put these limits, so this is coming out as e to the power minus infinity minus e to the power 0, because when you put this 0, so this is x is equals to 0, so minus 0 is of course 0. So we know that e to the power minus infinity is 0 and e to the power 0 is 1, so this is minus 1, and we are having another minus outside this bracket, so this is coming out as 1. So since fx satisfies both 1 and 2, hence it is a PDF. Okay, so this is how we can check whether a given function is a PDF or not. Before we proceed further, let us take another problem. So if you look at this problem, so again we are given a function, and this function is defined as, again this function is defined in parts, so it is defined as 1 by 4 x square minus 1 over the region mod x less than 2, and it is 0 otherwise. Okay. So first of all, if you look at this mod x less than 2, so first of all we have to be very clear about the definition of the PDF, or sorry, this function fx. So if you look at this mod x less than 2, so this implies that x lies between minus 2 and 2, because we know that if mod x is less than a, so this implies x lies between minus a to a. So here if you replace this a by 2, so you will get this. So keeping this mod x as this, you will obtain the fx as 1 by 4 x square minus 1 for minus 2 less than x less than 2, and it is 0 otherwise. Okay. So this is how we are having this definition. Now if you look at this, so if you again consider this real line, so suppose this is minus 2 and this is 2, so in between this minus 2 and 2 we are having 0, and if you put x is equals to 0 here, so because x is equals to 0 lies in this interval. Okay. So when you look at the value of this function at x is equals to 0, so f at 0 will be 1 by 4 0 minus 1, so this is coming out as minus 1 by 4, so this is less than equals to 0. So means this implies that this is not a PDF. Why? Because it is not. So you can say, since fx does not satisfy the property 1. So this implies that it is not a PDF. Okay, so this is a very simple problems on based on the PDF, or you can say the probability density function. Now suppose let us discuss the second type of problem. So let another problem. So means if you are given that, suppose it is given that fx is equals to cx square. Here this x lies between 0 and let's say 3 is a PDF. It is given to you that this function is a PDF. Now we have to find this c. So if you look at this, because it is given that it is PDF or the probability density function, so it satisfies both the properties. Okay. So since fx is a PDF, so this implies it satisfies both 1 and 2. So again, as I said that in this case we will make use of this property 2, means when we integrate this fx over this domain, so the value of this integral is always 1. So if you look at this, So our domain is this 0 to 3. So if you integrate your function which is cx square within the limits 0 to 3, so we know that it is 1 because it is given that this function is a PDF. So this is coming out as c times x cube by 3, and the limits are 0 to 3, and we know that the value of this is 1. So from here you will obtain that this is c times, and when you put the limits, so you will get 9 minus 0 is equals to 1. So this implies 9c is equals to 1, and from here you will easily obtain the value of this unknown as 1 by 9. So this is how we can obtain, or how we can deal with the problems related to the probability density function. So let us discuss one more problem on the second type. Means here we are given another function, or you can say the another PDF, and we have to find out the unknown involved in the definition of this PDF. So here we are given this function as ax, and this is when x lies between 0 to 1, and it is a when x lies between 1 to 2, and it is 3a minus ax when this x lies between 2 and 3, and it is 0 for x greater than 3. So you can see from this definition that in order to get a clear understanding of this definition, you can consider this as real line, and this real line you are having from 0 to infinity, because you can see that it is defined from 0 to infinity. This is not defined from minus infinity to 0, because you can see that it starts from 0 to 1. So let us mark this as 1, 2 and 3. So on this 0 to 1, this function is given as ax, okay, and on this 1 to 2, this function is defined as a, and from 2 to 3 it is defined as 3a minus ax, while for x greater than equals to 3 it is 0. So because it is given that this is PDF and we have to find the value of a, okay, so it is given that it is a PDF and we have to find the value of a, okay. Now we again use the property number 2. So it is given that it is PDF, so because it is defined from 0 to infinity, so if I integrate from 0 to infinity this fx, so this integral should produce 1. Now because this function is defined in parts, so you can take this as 0 to 1, because 0 to 1 it is ax plus of course dx, and from 1 to 2 this is a dx plus 2 to 3 it is 3a minus ax dx plus 3 onwards, so you can consider this as 3 to infinity. The function is 0 dx. So from here you will obtain, and of course this value should be 1. So from here you will obtain a is a constant, so you can take it out from this integral, and when you integrate x, so this value is x square by 2, and we are having the limits as 0 to 1. Again a is constant, so when you integrate here, so it is coming out as x, and you are putting the limits. And here you will again take this a outside, and you will obtain this as 3x minus x square by 2, and limits are 2 by 3, and again here the function is 0, so this will be 0. The value of this integral is 0. So now when you put the limits, so this will be a times 1 by 2 minus 0 plus a times 2 minus 1 plus a times 9 minus 9 by 2 minus 6 plus 2. Okay, so this is what we obtain here, and of course the value is 1. So from here you will obtain a by 2 plus a, and here you can see that it is coming out as a by 2. Okay, because when you add and subtract these numbers, so you will get 1 by 2, so 1 by 2 into a is a by 2, and this is 1. So from here you will obtain 2a is equals to 1, and from this you can easily obtain the value of a as 1 by 2. So as you can see that these are some simple problems based on the PDF of a continuous random variable. So that's it in this video, and we will come again with some more problems on the continuous random variable.